So it's been a little while since I recorded the phase 3 video, and honestly, I cannot remember if that discussion. Oh, Ben's phone just fell to the floor. I cannot remember if that discussion is in there. So, all right, and now the sound is actually coming out as well properly. So now we can do this again. I don't remember if the video for phase 3 correctly talks about how to implement the check method for checking whether all abstract methods have a concrete counterpart. So somebody who has watched the entire video, tell me if there's some discussion about that in there. If not, then I'm going to force you to sit down and watch it with me, and it's over 2 hours long. Yeah, just like the lady at the T-Mobile said, now that you have 5G and you can download things faster, you've got to get more data. I'm like, why? She goes, well, because now you can watch things faster. I'm like, no, I can't. I still have to watch it in the 223, as far as I remember. So that's the length of it, or is that where the discussion of the of this stuff is? It's probably the length of it, if I'm not mistaken. So nobody knows. That's a bad sign. So in the book, this is somewhere. It's on page 429. Yes. So the check implementation of abstract classes done the dirty way. So let's actually just talk about this because we got to do it at some point anyways. And now is as good time as any because we're doing it in phase 3. It's in chapter 7.3 in the book. If you want to go look it up. So let's just write down what an abstract method is and a concrete method. So an abstract. So this is in 7.3. So an abstract method has no body, and a concrete method has a body. Right, so that's not difficult to understand, and as a corollary of this, any class with an abstract method must also be abstract. That should be pretty clear, because what happened if you instantiated a class that has an abstract method in? Well, now you hold onto an object on which you can invoke that method. And what happens if you invoke a method without a body? Well, then there's no code to run. Cannot therefore be instantiated. Right. So the assignment approach. The assignment approach is, I think, what Matthew called dirty. I think. Just give me a second. I'm just about to die in snot. All right, I think I'm surviving. Let me just have some coffee. Okay, so I called it the dirty, the dirty approach. It is because it doesn't always work. It works quite often, and it's very simple to implement. It just says step 1, split the list of all methods into an abstract list, or we should say into a list of abstract methods and into a list of concrete methods. Then check that each abstract method has a concrete counterpart. So just basically a for loop to split things, and then a double for loop to check things out. But let's let's code a little. Let me share my see if we can find something here. There we go. Terminate that one. And is this another one there? Like squishing cockroaches. Right. So let's try something. Let's make a class here. If I can actually do this. Public class A. Void foo, and we'll make that abstract, and therefore that abstract, like that. And then we will say class B extends A, and we'll say void foo, and then we'll say, make that public as well, public class test44, public static void main string args, and then we'll say B equals new B. Oh, and just for shits and giggles, we'll do that as well. Now, the question is, will this code compile? I mean, we could just, now I already typed it in, I could try to run it, but I mean, we could look at it and try to figure out. Dennis says yes. All right, that's good enough. Well, we'll try it then. And yes, that seems to be just fine. You're of course allowed to declare a variable even of an abstract class, because the actual value that goes in here is never from an instantiation of an abstract class. Right. Now, of course, we have a problem down here because I can't instantiate B at all because it's abstract. But what if I do this now? Public class C extends B. So how about that? Will that compile? Or should it compile? Now, those of you who are already done, you can try to run this through yours. All right, so Dennis says no, because foo doesn't have a body in C. Okay. So what if I swap these around again? So what if I made that abstract took away that body, did this, took away abstract from that one, and made this one the good one. What about now? Does that make any difference? So you say you don't think so because B is still an abstract class. So if we look at this code, this code is actually perfectly okay, and we can compile it and we can see that it works. And the reason it works is, of course, if I look at C and I say, all right, what methods can C access? Well, anything that is not private that comes from B or above. Well, there's an implementation of foo here, and that re-implements or overrides this this abstract one up here, right? So that's perfectly fine. Now we actually have, we're never in a situation here, if you think about it. Can I instantiate anything here, A, B, or C, in such a way that I get an abstract method? Well, no, because if I instantiate C and invoke foo, then I get this one. Oh, sorry, this one shouldn't be abstract. There we go. You could have declared it abstract, it would have been perfectly fine. It would just mean that you couldn't instantiate it. It still compiles. You just don't, you're not allowed to instantiate it if it's abstract. So the rule is if you have an abstract method, the class must be abstract. But if the class is abstract, you don't have to have an abstract method. So if I instantiate this, this is my foo. And if I instantiate this, that is my foo. And this is abstract, and I can't instantiate it at all. So now let's go back to what we had before. There we go. So is that legal? Now. Well, no, because if I call foo in C, I get that one. If I call foo in A, I get that one. So I can actually end up inheriting this one because this abstract version here now overrides this one. The problem, of course, is that if I want to do the dirty approach, which is the one that's sort of described in apparently in the video, but definitely in the assignment, and it is, if I look at the all methods that we get in get class hierarchy methods in test 44. Let's see what Benjamin says. He says, just to make sure I heard correctly, if it's an abstract method, you need to have an abstract class. Correct. But an abstract class does not need an abstract method. Yes. So if you declare something abstract, even if it doesn't have any abstract methods, then it just basically means you can't instantiate it. So yes, you're correct. So if I look at my all methods, which is the one we created in the get class hierarchy method, then there's going to be this main in it. It's going to be this void foo no body, and there's going to be this void foo with a body. Now if I then make two separate lists, one with concretes and one with abstracts, then this guy goes in the abstract and these two go in the concretes. And now I just got to ensure that everything in the abstract list, which is this guy, has a counterpart in the concrete one, which is this one then. So we're good to go. But in reality, if I try to compile this, oops, then it says class C is not abstract and does not override abstract method void foo. So if you do the one that's in the assignment, that's perfectly fine. Should we give extra points if they do it the other way around? Like, for real? If they do, like, the proper implementation that I'm about to explain? Is there a test for it? I could write a test for it. Ben is very enthusiastic about giving you extra points. We really should have him. We should have him on the little camera, sort of at the corner up here. Right. So let's shall I make a couple of tests and then we can do like 5% extra if you implement that instead.
Just like add that to the test bank in your directory. Just have
Oh yeah, so if I add that one, and if they however many of these, I think I can probably just get away with just one or two. But if both of those pass, then we'll add another 5% to the total.
yeah.
Yeah.
And we'll just add that in espressos. Or do you just want the base?
I don't know, or I'll just post them online, and then I'll send them to you or something, and we can incorporate them later. We'll figure that out. But so
Actually,
yeah, 5% extra if you implement what I'm about to tell you. Right. So let me tell you what I'm about to tell you. Well, if I tell you that I'm no longer about to tell you, then I am telling you. So let's start out with the code that we just wrote. So I'm just going to rewrite something very similar here. So let's do a class A. And let's put in here public void foo with a body. And then we'll do an abstract class B extends A. Now, could you imagine if they had actually made this a lot easier, just to say CL for class, PU for public, VO for void, extends just like the less than symbol? We would all be typing so much less. But then you get nonsense languages like Aldwych, which is just gunk. So that one is the abstract one. And then class C extends B. And that was the one where we got into trouble. If we try to do this, then this code will pass just fine, won't it? If you do the separate into abstract and concretes and then just check that all the concretes, sorry, all the abstracts have concretes. So let's try something here. We're going to define a function, and unfortunately, I don't know why. I ended up calling it M, which makes no sense. But I think I ended up calling it that because that's what it was in my implementation, and I was too lazy to come up with a better name. So you can call it whatever you want. But it's just a function that takes in a class. So this is it's not this class, it's a class, right? So that's a class. And what it does, it gives me a pair back of abstracts, methods, and concrete. So far, there's nothing different than what you would do otherwise. In the simple implementation, you would indeed compute the abstracts and the concretes. And then let's just define also MC sub abs is just the abstracts. And MC con is just the concretes. Right. So now we can go through all the possible shapes a class or an interface can have, and then we can see what falls in the abstracts and what falls in the concretes. So let's start out simple. So we'll start with just an interface. So if I say interface I, and all methods in an interface are abstract. At least they are in Espresso. I think in new Java you can have non-abstract interface methods. Right, and then I will ask the question, what's M of I? Well, there are no concretes and everything is abstract, so A1, A2, dot, 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 AN, and this one here is empty. Right? Cool. So what's the next thing we could come up with of making, in order to make this more complicated? Well, we could try to give this interface some super interfaces. So if I say interface I extends I1, I2, dot, 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 IM, and the rest is same. If I can figure out how to copy it, there we go. So we get that. And then we can ask again, what's M of I? Well, it's definitely all of those. But we also have to union onto that all the abstracts in these super interfaces. Well, that's easy enough, because we'll union that with a big union in which we say I starts at 1 and goes to M. And then if I apply the M function to I sub I and take just the abstracts out of that, because I know there aren't any concretes, right? And then, of course, the concretes are not there. Right, so not too complicated. So let's move on to, we've done basically all we can with interfaces. So let's do a class. And what should we call it? C. We'll start with a simple class. And we can put in an abstract method A1. Abstract, oh, I should probably put a, did I put return types on these other ones? I didn't, my bad. So just do that. There we go. So we've got some abstracts and we have some concretes. And then we can again ask, what's M of C? Well, that's easy enough, right? Because it's my abstracts in the abstract part and my concretes in the concrete part. Okay, so not completely complicated. Let's make a copy of this. And let's go here. Put it there, because that gives me room to put a 4 here. And then we'll just give this one now give it that. Right, so so how does this work now? Because now we actually have to start thinking. Because if I consider M of C, actually let's do it in two parts. Let's look at M of C abs and M of C concretes. Now, I know that my own abs go into, so my own abstract methods, these guys here, eventually must end up in here. But I might also have inherited some from here, right? So whatever abstract methods I inherit from S, if any of those are re-implemented by these concretes, then I got to take them out. So if I say, right, give me the abstract ones of S, take away whatever might get implemented in C, and then add into that all my abstracts. Now, how does it work for the concrete ones? So, for sure, those concrete ones are 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 available in here, and you cannot have the same concrete and abstract in the same class, because then you would have two methods with the same parameter signature and all that, and that wouldn't work, right? But if I inherited a concrete method from S, which is made abstract here, then that has to be removed. So we can now here say that this is the concretes I inherit plus my own concretes. But take away whatever I make abstract. Oh, this should be an M here, right? There, and this should be an N. So we get something like that. Right, so what else of craziness can we come up with? I think the chat has gone completely dead. I think everybody's fallen asleep. They don't want the 5%. And Ben just looks angry now. Bet you his code doesn't run.
Python sucks.
Python does suck, but we knew that.
How can you call yourself a language if you don't have a switch case?
Don't they? Well,
They also don't have bold comments. But the bold comment is a frickin' string.
so Mason says, how about if there is an override method? Concrete. Not entirely sure what you mean. So can you elaborate? While you type that, then I'm just gonna fiddle with this here, and then we'll come back to your question once you've typed it out, or you could just unmute, whichever you want. So here's the craziest thing we can do: is we can extend one thing and we can implement. So override a method from a base case. Well, for concrete or non-concrete. So if a concrete one overrides one from up here, that is also concrete, well, then it just stays in here, right? Because those concretes are there and they are also here. So these are set. So whether you have it once or twice doesn't matter. You just get it once. And if it's an abstract, then you can see that it gets removed from the concretes here. So if you inherit a concrete one from up there, and it's listed in that list, then it gets removed from there. So this is the ultimate now, right? But this shouldn't be too terribly bad, because I know that everything everything in here are all abstracts, so I can only ever inherit abstracts there. However, let's just go back to this here for a second. So what if I do, this is A, and I'm going to make public class B extends A, and I'm not going to make it do anything. And then I'm going to throw in an interface. And in there we shall put void true, like that. and then class C extends B and you don't type the and. Implements I, and C equals new C. Is that legal? So in other words, will C have inherited, well, it inherits both a foo that is abstract from the interface I, and it inherits a concrete from a superclass A. Which one takes precedence? Precedent. I can precedence. What's the difference?
Precedent.
I think it is precedent. Because I always get it wrong. Difference between yes, precedence, and precedent. Precedence versus precedent versus precedence. Okay, what do I need to know? Just tell me what it means. Precedence, partly influenced by the French précédence or something, meaning priority or preeminence. Whereas the other noun, on the other hand, the noun precedent is frequently used in the phrase to set a precedent, meaning to take it. Oh, so I need precedence. Okay, fine. So we learned something today. There we go. To all those people who don't speak proper English. Right. So Dennis says interfaces I foo because it's closer on the class hierarchy. So I think that if this approach that we're taking now, where we can sort this out by just sort of doing set unions and set differences, would not work if this idea of closer had to come into play. So I don't think that would work well. What does Matthew say? I think in the recursive stuff we usually do, we check superclasses before interfaces. So maybe the superclass that comes up first. Well, yes. So that's a good point. So really, it becomes a question of, do I union the stuff in A before I subtract the stuff in I, or do it the other way around, right? And let's see. Yes. So it turns out that the appropriate, so let's just see if this actually works. It does work. So it says it's fine. So what happens is that these inherited, this inherited one can be seen down here. And since in this interface, as long as you promise to implement that, then you fulfilled your deal, which means that this does not take precedence over that. This one is more powerful in binding. So we got to take that into account when we do this. So if I say, let's see, M of C, let's just look at the abstracts, then I know I have a bunch of abstracts that have lower precedence. So let's go grab those first. So that's all these I equals 1 to n, M of I apps. And then I have some apps myself as well, probably. Oh, my superclass, sorry. And from that, get our brackets right, we can now remove our concretes. So C1 dot 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 CM. And we can also remove the concretes that we get from our superclass. So we'll just union that onto there. Like that. But then finally, we better add our own abstracts. So there we go. Now what about the concretes? Well, I get some concretes from my superclass and nowhere else. Oh, you can't see the board. Sorry. Well, then, when you can't see the board, unmute yourself and shout "board" or something. I mean, not bored, but oh, that is the same word, isn't it? That's unfortunate. All right, that's a dumb idea.
Isn't another thing?
Yeah, we got to sort that out as well. We got to come up with another word for that. Whiteboard. I suppose that could just be that could be a semi-racist term. I don't know. Right. So, what about the concretes? Well, the concretes are fairly easy, and I think actually they are exactly the same as that, because adding a bunch of interfaces that never have a concrete method in is not gonna be a problem. They don't even factor into it. So I get my concretes from my superclass plus whatever I have minus whatever I abstract away. There you go. So now we can say the following. If for a class, I don't think this is good English, but still, if for a class C, it isn't good English, so we do it properly. For a class C, comma, for a class C, not comma, if, comma, M of C abs is not equal to the empty set, comma, then the class should be declared abstract. So there we go. That's all there is to that. So if you choose to go and implement that, that will be cool. And will be 5% extra. And are you muted or unmuted? You sure? Oh, that's why. Okay, cool. No, it was just because I heard. Oh, there we go. So, quick question there. Is it legal to have a function without a body that isn't declared using the abstract keyword? Not in a class. So in a class, if you don't provide a body for a method, you must put the keyword abstract or the modifier abstract on it. However, I don't think you have to do it for interfaces. Yeah, no, I don't think you do. Oh, by the way, the entire algorithm is in algorithm 21 on page 433. So those are easy 5 points or easy 5%, isn't it? If you got a book. Yeah, I suppose if you don't have a book, you're kind of like in trouble, but you can just go implement it, right? It's all in here too, right? I mean, there's nothing you really need the book for if you, well, stop saying that. Yeah, I mean, no, I think the book is an excellent resource, and it will definitely help when we get to phase 6 and all the parsing stuff. No, it's a wonderful thing. You can also use it to read good night stories to your kids because there are fun facts in the book, and I'm sure they would much rather fall directly to sleep than they would want to listen to that nonsense. I wonder if the other Ben is using the book for that with his daughter. Right. So there we go. That's that. Are there any comments on this, or oh well, this was so boring. There's 2 people left. Oh, you just left. Oh, because you already know this stuff. So Any questions on any other questions? Or should we go back to where we were? Somebody remind me to post. Oh, you were supposed to remind me about that other stuff.
I just did.
I know, but I forgot again. Now I remembered. So for those of you who have a DRC, which I think is probably only one person, could you send me an email just so we can get on the same page with how we're gonna? I think it's an extended time, and I think we know how to do that in. Ben says yes. So if it's just an extended time, just send me an email and remind me how much extension it is. That I can probably find the email just to verify it. But it would just be nice that that just in case that an email had gotten lost, that nobody gets any surprises. So just shoot me an email if you have a DRC. Right, Marion. I suppose your question mark I can answer it with that because I don't know what that question mark means. And if you say what's a DRC, then all I have to tell you is you ain't got one. Yeah. So, Desert Research Center, Department of Recreation. Yes, put that on the list as well. Since we are there we go. I didn't see that. Since we are in question moment, is the midterm at class time? Yes, it is at class time. So definitely show up for that one. I suppose we should probably announce that. 7th, right? It's the 7th, right? Or was it 12th? It's the 7th.
Yes.
7th.
Assignment's the 12th.
Yes.
Exam's the 7th.
So Ben wrote down both of them, but stubbornly didn't actually put down what they were, so we don't know. The bookkeeping is not going well in this office at the moment. Huh? What do you mean? All right. Well, there we go. Yes. So maybe we should send out an email. Remind me before we go home today to send out an email to everybody that it's the 7th, because then nobody can complain about that. Because since will there be a study guide? There will be absolutely no study guide whatsoever. And if you insist on getting me started on telling you why, this could be a very, very long lecture. And there won't be a review either. It is completely and utterly inhumane to come to this class. So you are completely and utterly on your own. No, so here's why there won't be either of those. First of all, it's not my job to make study guides. It's your job to make a study guide. You're the student. I'm not. I have made the lecture guide, which is called the book, and the lecture notes, and I even have the videos, and you even get my lecture notes. And here comes the, oh, Jesus Christ, old man, just shut up speech. When I was your age and I went to school, I didn't take any notes, and I don't know why, but I don't seem to be able to find any notes that I've ever taken on anything. But don't do what I did. Do what I say you should do. So no, because I have a sneaky suspicion that a study guide, and I'm sort of air quoting, is a sneaky way to say, oh, Professor, can you just boil down everything you said to the fewest number of pages so that I don't actually have to read any of it and bother understanding very much of it, but just the necessary things for me to scrape by and get the grade that I need. And of course, that doesn't fly, at least not with me. So you are, what was it Gerald and Jessica called me back in 2004? Cruel and unusual, I think it was. And then she ended up taking another course from me. She was funny. No, it's your responsibility to read the book, study your notes, or in this case, my notes, or review the videos if you feel that that's necessary. You have all the resources that nobody has ever had before, right? Because we've never been able to record this stuff and put it out in multiple issues and notes, and and all this stuff. So there are more resources than one could ever imagine. So that was for the study guide, and for the review, I will do review for the final, and we'll do that sometime. I'm actually leaving on the Sunday, so I'll be conducting. Ben will be the local rescue hero, and I will actually be in London, so doing it remotely. So we could go to hell in a handbasket, but Ben promised to save the day if it all goes to hell, right? Well, no, now you have, haven't you? Yes, now you've done it. See, you all heard he said yes, didn't you? There you go. So that'll be something from like, what time is the exam? 6 o'clock? 6. Oh my God, that's from 2 to 4 London time. Oh, that'll be fun. But so we will do some reviews. We'll do a review before, probably on the Friday or so. If you do better on the final, the midterm doesn't count, and I don't want to do a review session on the midterm, simply because this is a great opportunity for you to realize that maybe you should take this a little more serious, study a little harder, and pay a little bit more attention, and show up to lectures. Well, if you're not here, you wouldn't hear me say that. So, it's just a way to, maybe realize that this requires a little bit more attention than you've been previously.
Also remember that the midterm doesn't really count much.
No, and the midterm doesn't count. If you don't listen, if you don't want to take the midterm, then don't come and take the midterm. Then go do something else. If you feel that you're going to do better on the final anyways, then don't bother if you don't want to. If you want to take it and then use it sort of as a practice to see where you are, that's fine. And if you think you're going to do worse on the final, then definitely take the midterm. But if you miss the midterm, it is by no means a big deal at all, because we'll just count the final for another 10%, and then that's the end of that. Right, comments, let's see. Ryan says, and I didn't take any notes, and history repeats itself. I don't know. I didn't take any notes in any classes, to the best of my knowledge. I have all my material here. I mean,
I stopped taking notes towards the end of my bachelor's.
let me just.
I tried taking notes in your paradigm class, and then I just gave up.
So, so there you go. Use that one. There are all my, not notes, but all the material from when I went to school. But none of that contains any of my notes. So I don't know. I don't know what happened with that. But that being said, my lowest grade ever that I ever got in any course was in compilers. So yeah, maybe I should have.
Same with me, 218.
Yeah, we got you good on that one, right? Right. So Marilyn says, "Do I know up to what lecture date the material on the exam will cover?"
The day before the exam.
No, up until today. Yeah. So if any of those, well, sure, up to and including today, we're not gonna do any of the bottom up stuff or the SLR parsing on the midterm. There might be some of those questions on one or two of the old ones, but you can just, I mean, if it's some sort of material that we have never covered, then I would never ask questions about it, because that would just.
It looks completely.
What's the kernel again? Right? No. So don't worry about that. What did?
Kernel.
Kernels?
You said the word kernel, and I'm like, huh? Excuse me, I thought this was compilers, not OS.
Or chicken frying. KFC. Ah. No, actually, I haven't had KFC for years. So yeah, up until that time, and if yeah, I think that's about it. Now, any other questions, or can I say something about bottom up parsing that will not be on the midterm? Because it's a little early to leave. Yeah, no, I'll get this started. So I can't remember if it was yesterday or if it was sorry yesterday during office hours, or if it was last time we had class. Somebody asked a really clever question, I thought, and I actually sort of had to think about it for a little while. But the answer was really kind of obvious, and that is, what's the difference between a leftmost derivation and a rightmost derivation in reverse? I mean, there's some obvious answers, right? One goes in one direction and the other one goes in the other direction, which is kind of obvious if you think about it. But why even bother with the rightmost derivation in reverse? Why don't I just do rightmost derivations? And let's try to sort of give a good reason for why rightmost derivations are terrifying things to try to work with. So let's start with an example with a reasonably simple grammar that just says A, B, C, and A goes to little a, or epsilon, B goes to little b, b, or epsilon, and C goes to little c, c, or epsilon. And let's consider a string that is A, B, B, C. I mean, first of all, is this grammar LL1? Yes, no? Yes. No, first sets intersect. Well, at least not first sets that aren't supposed to intersect, because that one and that one does. But so there's only one hand side there, so that's fine. First here is A, that's an epsilon. That's a B, that's an epsilon. That's C, that's an epsilon. No problem. Good. Right, so let's see if we can derive this string in a leftmost derivation. So we got to go A, B, C. Right, so what do I do if it's an A? Well, then I probably go A, B, C. So now we got that one taken care of. Then we are out of A's. So now we got to do an epsilon guy. So we'll say A, B, C. Actually, so if I just say here, what did we use here? We used S goes to A, B, C. Here we used A goes to A. Here we used A goes to epsilon. Then we get A, B, B, C. And we get A, B, 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 C. Then we get A, B, B, C. And then we get A, B, B, C, C. And finally, A, B, B, C. And let's just fill in what we did. B goes to B, B. B goes to B, B. B goes to epsilon. C goes to CC, and C goes to epsilon. There we go. So when we do the leftmost derivation, it's easy to tag along on the input, because every time I produce, so we can just try to highlight that here, can't we? So every time I produce a new terminal, actually let's do that one in a different color. Then I can match along on the input, can't I? So there's that B, that's that B. And where's my C? There's my C. There's the C. Right? So as we read the input from left to right, and reading the input from left to right one look ahead at a time is nice, because that seems very convenient. Now let's try a rightmost derivation of the same thing. So W is A, B, B, C. S goes. So now you'll see almost immediately what the problem is. what happens now? Well, if we're doing a rightmost derivation, then we have to we've got to do something with C. But C cannot produce any of these guys, right? So we've got to sort of go look down towards the end of this file in order to find the C's. So in order to do that, so let's just try to do this actually. So we get A, B, C, C. And what do we get there? We get A, B, C. So now we're sort of moving further to the left in the input because now we've dealt with that. And then we get A, B, B, C. A, B, 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 C. You can see how this is a complete mess, right? There we go. And let's see what do we get here. S goes to A, B, C. C goes to C, C. C goes to epsilon. E goes to B, B. B goes to B, B. B goes to epsilon. A goes to A, and A goes to epsilon. So we actually use the exact same rules, which is good because we're supposed to. Otherwise, the grammar would be one of these wonky, unambiguous ones. But you can also see that using the ability to look ahead one and then say, all right, fine, we've matched the A. That doesn't really work because if I look at, let's see if I can use the same colors here. So where did I match the C? Well, that C is there. And where's the B? Well, the second B is there. And the first B is there, which puts the A here, right? So you can see that this is in a completely different order. That makes life complicated. So if I look at this and I say, which one of these hold on just a second. There's something here that bothers me, which is well, never mind. So what if I did this in sort of a backward order instead, and I said, all right, that A surely is this A here. So if I could deal with that first, well, how do I get to this point from here? So if I'm doing a reverse most right derivation, then let's just remind ourselves that in a derivation, we pick a non-terminal, and replace it by a right-hand side. So we pick a non-terminal x and replace it by a right-hand side alpha. So i.e. x goes to alpha is a rule. So nothing complicated about that, and we do that both for left and rightmost derivations. The only difference is how we pick which non-terminal to do. In a reverse derivation, well, we do exactly the opposite. We replace a right-hand side by a left-hand side. So we find a right-hand side, i.e. alpha, and replace it by its left-hand side, x, such that the new sentential form is the previous one in a rightmost derivation. That sounds awfully complicated, and it is. Because if I just do, I'll take this. Oh, by the way, there's one other thing I wanted to say. So we'll just finish this, and then I'll say that. So I'm going to put that there, and then I'm going to say A, B, B, C, and then I'm going to ask you, what was the previous sentential form in a rightmost derivation of this string? So just looking at that, can you, well, you get to look at the grammar as well. Can you tell me what was the previous step? So Michael says, so what we say, so when we say rightmost derivation in reverse, the in reverse part refers to the input string being read in reverse. No, it doesn't. It refers to the derivation being done backwards, right? Because that's what I'm asking now. And Dennis says ABB capital C little c was the previous step. Well, you did the rightmost derivation, and no, it wasn't. And this one was the previous step, because I'm doing rightmost derivations, right? What was the previous? What was the previous sentential form in a rightmost derivation of this string? Right. So the answer was A, B, B, C. Right. So by using A goes to epsilon backwards, right? So it looks to me here like we have a number of options. I mean, this was easy because we went to the previous page and we said, I did the rightmost derivation, no problem, so there it is. But what if you actually haven't done the rightmost derivation, because it's difficult to do the rightmost derivation, so we don't have a way to cheat and look, right? So could I convince you that how about those? What, well, I mean, or perhaps even that, or that. I mean, where do these come from? Well, they come from the fact that I see epsilons everywhere, right? So what we need to do is we need to find a right-hand side. Well, I can find a right-hand side because these epsilons are fairly easy to find. There's one here, 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 and here. And I can replace it by any of those because they all have an epsilon side. Now, the problem with doing that is that if I replace the perceived epsilon here with a B or a C or even an A, then I get myself into a situation where the sentential form that I create by doing the replacement of that epsilon by, say, that A, gives me a sentential form that couldn't have been derived from the start symbol. So not only do I have to find a right-hand side, somewhere nestled in between all this, in whatever sentential form I'm looking at, I got to find the right one. And the right one, of course, is that one. So after we've done that one, then we better find that one. And then we have to find that one. And we can see with this guy here that I do have some options here as well, because we could, well, actually, so we can look here. This part, well, that matches this and could become an A. But I could also say there's an epsilon there and put A, B, or C, an epsilon there, there, or there, and put A, B, and C. And only one of them is the correct one, which is the one that gets me back to here. And then after this, then magically we got to pick this epsilon here in order to get that B in. Now we have that, which gets to be a B. Now we have this that becomes a B. Now a magic epsilon appears here, so we get CC. And now we're back to ABC, which is the right-hand side of that, and we can reduce it all back to the S. So we'll come back and look at that later. However, there is one thing I just wanted to point out because this caused some issues. Not that one. It can't be that one either. This one? This one. This one? That one maybe. Why can't I find that one? First. No, no, no. 14. Not 14. 21 then. It's got to be this one. Yeah, it wasn't. So this one maybe? Isn't there some way I can see all the slides? There we go. Nope, not that one either. What about this one? Nope. That one? Yes. It's exactly the one. So real quick here. Be careful when you read this slide. And take note of what it really says. This says here, these two things in yellow ensures that we get the same behavior as the recursive descent parser, which is this piece of code, because that says if it's a look ahead of plus, do this. If it's a look ahead of minus, do that. Otherwise, because there's an epsilon, then otherwise take the epsilon. So we never error out, which means that these two both get filled up with the epsilon in order to get the same behavior. However, and that's what we use in this example here. However, then it says here filling M. So this orange thing says this results in the same behavior as the recursive descent parser. But you can see that this has an arrow there, not that. So if epsilon is in the first of alpha, then at the end of at the end fill the empty cells in row X by X goes to alpha. That results in the same behavior as the recursive descent parser. However, let's do better in purple. And that says if the epsilon is in the first of alpha, then only do X goes to alpha for B in the follow set of X. And the follow set of E prime here is $, so therefore we only put it in there and error out on that one. So remember that. Done. So now we just got to find our way back to there. Right. Any questions? Nope. See you next week, I guess. Or tomorrow. No, not tomorrow. No, tomorrow. I'm getting vaccinated again tomorrow. So have a good weekend. See you Monday or Tuesday or something like that.